Hello friends, welcome to the next session. Here we are going to study the second problem on pumping lemma for regular language. And now you will realize that the things are getting much more simplified. So the question over here says, we have to show that the language L is equal to a raised to m b raised to n where m's value is greater than n is not regular in nature. As you can see, I have kept all of the steps same and only few things are going to change over here. So I say, let us assume that L is regular. It is accepted by the finite automata with n number of states. Let W be a string accepted by the machine. Therefore, mod of W is greater than what? I have a raised to m, b raised to n. So I have to simply add up m and n. Because in the previous case, we added up n with n. Now we'll be adding m with n. So mod of W is greater than m plus n. So that's what has changed. Later, here as we don't draw DFA, we take the pumping length as n and therefore we write P is equal to n. Fair enough. Further going ahead, the things remain the same. Now we have to divide this W such that XYZ, where X consists of S number of A's where S is greater than equal to 0. Then Y consists of R number of A's where R is greater than 0 and Z consists of the remaining part. So now over here, I say over here, as we are considering a raised to m, b raised to n where m's value is greater than n. So can I say in this case that since m is greater than n, so maybe in this n, if I add a number maybe called as x, I will be able to match up to m, right? Because m is greater than n, so by adding x into n, I come to m. So now, of course, x has to be greater than equal to 1. So now over here I say, why can't I write the same thing as a raised to s, a raised to r, where this is my x, this is my y as usual, and the next part over here, as it is a raised to m, a raised to n, that has become a raised to n plus x, b raised to n. So among this n plus x, s number of a's are out and r number of a's are out. So what is pending is a raised to n plus x minus s minus r, right? And b raised to n, this entire part is contributing to my z. As simple as that. Our breaking is always going to be in the same manner. I'll tell you once again, a raised to m, b raised to n was modified to a raised to n plus x, b raised to m because we have substituted m's value by n plus x because m is slightly greater or maybe higherly greater than n by x amount, and that x we have added in n itself and substituted in place of m. Now among this n plus x number of a's, I removed s number of a's out as we did in the previous problem also. Then I removed r number of a's out again as we did in the previous problem, and the remaining part would be n plus x minus s minus r number of a's that we just removed out as x and y part, and the pending part or the remaining part will be considered in z. So let's go ahead. Now mod y not equal to epsilon condition is going to get satisfied, of course, because r is greater than 0. My mod of xy less than n condition is also getting satisfied. Now we check for x y raised to y z. So if I say I is equal to 0, I get xz. So let me write the xyz first. So that is a raised to s, a raised to r, a raised to n plus x minus s minus r b raised to n. This is my x, this is my y, and this is my z. Now, if I say xz, it is now going to consist of a raised to s, a raised to n plus x minus s minus r b raised to n, which further gives me s and s cancel out, So I have a raised to n plus x minus r into b raised to n, right? So over here we realize number of a's are lesser than number of b's, because this can be further substituted as a raised to m minus r b raised to n, because we know that n plus x is nothing but m. So m is greater than n condition is not getting satisfied over here. Further going ahead, if I consider xyz, what I get over here is back the same thing, a raised to s, a raised to r, a raised to n plus x minus s minus r b raised to n, which is a raised to n plus x into b raised to n, which is a raised to m b raised to n, where my number of a's greater than number of b's, number of a's greater than number of b's condition is getting satisfied. Lastly, if I consider x y square z, that gives me a raised to s, a raised to r, a raised to r, a raised to n plus x minus s minus r b raised to n. That gives me a raised to n, a raised to s gets cancelled out, a raised to r gets cancelled out, a raised to n plus x plus r into b raised to n, which is a raised to m plus r into b raised to n. Again over here my number of a's and number of b's condition is not getting satisfied, and therefore we say my xz does not belong to the language, xy square z does not belong to the language. Hence by contradiction we say that the given language a raised to m b raised to n, where m is greater than n condition, is not a regular language. So with this friends, we complete with this problem. See you in the next session. Thank you.